What's up, scholars? Today we're talking about surface area, which is literally the area a surface takes up, aka how much space something, that O came out wonky, how much space something takes up in 2 dimensions. Now, you've been finding area for a very long time. You know how to find the area of rectangles. You know that's length times width. You know how to find the area of triangles. You know that's 1/2 base times height. Let me just write that. A equals length times width, and triangle's area is 1/2 the base times the height. Now, I labeled the base and height strangely on this triangle to prove a point that the base of a triangle can be literally any side. Any side can be the base. It doesn't have to be the bottom side. You would think that it would be the bottom side, but it doesn't have to be. It could be any side. The height is the perpendicular distance to that base. The perpendicular distance to that base. That is the height. So anyway, finding surface area just requires us to split anything into a bunch of rectangles and triangles, and then find the area of the rectangles and triangles and add them all up. That's it. Okay, so let's say we have a problem like this. Olivia is decorating the outside of this box, which shaped like a rectangular right prism. The figure below shows the net for the prism. What's the net? Well, that's like if you sliced all the sides of the box and then laid it flat. So again, this looks like a box when you put it back all together. Put it all back together. So, just curious, what would this box look like if we folded these sides up? Like if I folded that side so it touched this side, and that side so it touched this side, and then that went back up, and then that kind of like wrapped around. Okay, so that's the other side of the box, and that's the top of the box. All right, I can see this. Cool. So, decorating this box looks like a rectangular right prism, a right rectangular prism, which is a box. What is the surface area of the box in square centimeters that Olivia is decorating? Why would Olivia want to know this? I don't know. Maybe she needs supplies for this box and doesn't want to buy too many supplies because that's spending too much money, and doesn't want to buy less supplies than she actually needs because then you have to go to the store again, and that's just annoying. So she wants to know exactly how much area am I supposed to be decorating, so how many supplies am I going to need to get for this decoration situation. Okay, well, we can find the surface area of this with no problem. So here's our picture. I left off the units because all of them were centimeters, so we don't need to worry about converting any kind of units. They're all centimeters, they're all the same units, which is great. So I left them off. I just put the numbers. This looks like a bunch of rectangles. Excuse my wiggly drawing, but this is a bunch of rectangles, so we just need to find the area of all the rectangles and add them up. Cool. So the area of this rectangle here is length times width, 10 times 12. There's that guy. So we have our total area is going to be a bunch of different rectangles added up all together. Maybe I'll just put numbers in them. The area of rectangle number 1, which is 12 times 10. Cool. The area of this rectangle here, well, we know one side is 11, but we need to know another side. We need to have a length and a width. Well, that is going to be the same as that, because those sides are supposed to match up, right? Those sides need to match up. So this must also be 10. So the area of this rectangle, rectangle 2, is, so we're adding these areas together, 10 times 11. Cross that off because I used it. Well, then that means this rectangle should be the same as that rectangle because they're opposite sides of this rectangular prism. So this guy, number 3, is going to be the same as that one, which was 10 times 11. Right? 10 times 11 plus 10 times 11. Now this rectangle here, we know this side is the same as that side, which is 12. We know this side is the same as that side, which is 11. So we're adding rectangle 4 here is going to be 12 times 11. 12 times 11. You doing okay so far? If you need to pause, go ahead and pause. We're just adding up areas of rectangles. That's all we're doing here. This rectangle here, we've got one side is 10. We need this side here, which is the same as this side here, which is 12, again, because my drawing is terrible. Doesn't look like it is, but this rectangle number 5, sorry, I don't know why I circled that 12, I just did. So that was rectangle 4. This is rectangle 5 plus, so we need a 12 times 10. 12 times 10. And finally, last rectangle, we've got one side is 11, one side, again, is still 12. All these are going to be 12. All the sides that are like parallel and in the same spot are going to be the same length. They have to be, so it matches up. So the area of this last rectangle, rectangle number 6, is going to be 11 times 12. Whew! We did the hard part. Now time for the boring part, where we plug all this into our calculator, which you can do and I can do off screen. So let's each do that together and see if our answers match up. Alright, so when you multiplied all of these individual rectangles, you should have gotten 120 plus 110 plus 110 plus 132 plus 120 plus 132. Interestingly, there are 2 pairs of each of the sides with the same number, which is actually not that interesting. That will always be how a rectangular prism works. You will always have 2 of the same side in a rectangular prism. Always will. So it's a good way to double check. Did I plug my numbers in? Do I have 2 of each kind? There you go. So then we're just going to add them up. 120 plus 110 plus 110 plus 132 plus 120 plus 132 is 724. I'm just going to double check. I never trust myself with a calculator, so I just always do things twice. 724. I got the same answer twice, so I believe myself. So I'm going to say 724. The units were centimeters. It's area, so it is squared. Moment of truth. Let's plug our answer in. 724 centimeters squared. Submit answer. Are you sure? Yes, I'm sure. I checked, and I got a green check for it. Here's the example of why. I don't even talk about it because we just did it. Okay, next type of question. Not as interesting, less context. Just says find the surface area of the rectangular prism. So we have a green side, a red side, a blue side. We've got some lengths 5 and 5 and 8. Alright, we can do this. And so what we know from last time, excuse my red and green. I thought that was red, but it's actually green. Whoops. What we know from last time is that rectangular prisms have 2 of each type of side. So there's 2 green sides, and there's 2 red sides, and there's 2 blue sides. So our area is going to be 2 times the green side plus 2 times the red side plus 2 times the blue side. Which I guess we could make that even simpler if we wanted to. All of these have 2, so let's just add up the green plus the red plus the blue and then multiply our whole answer by 2. That should be reasonable. We could do that. Okay, so the green side, area of the green side, we have a length here that's 5. We need a width here, which is the same as here, which is the same as here. Oh, okay, so that's 8. So 5 times 8. Green side is going to be 5 times 8. Plus the red side, we have a side length that's 5 here and one that's 8 there, so that's just going to be 5 times 8 plus the blue side. I don't have any numbers next to the blue side. No, but we can figure it out. I want this side. That's the same as this side, so that's 5. And then I want this side, which is the same as this side, which is also 5. So that is 5 times 5. Again, let's plug our answers in, lickety-split, and see if we match. So we should have gotten 5 times 8 is 40, is the same here. 5 times 5 is 25. Well, wait, now I only have 2 that are the same and 1 that's different. But, oh, that's right, because I said I took the 2 out, so these don't have to be the same. Like, they don't have to be buddies or anything. So then we just keep going on. 40 and 40 is 80. 80 and 25 is 105. And 2 times 105 is 210. And what were my units? I don't know. I can't remember. But they were something squared. I think it was feet. Anyway, I'm confident on this answer. Let's go plug it in. Oh, we were right. It was feet. 210. Are you sure? Yes, I'm sure. Correct. Delta math is sure too. So far this isn't bad. We're just breaking things down into rectangles and adding up the areas of rectangles. We haven't had to deal with anything with a triangle yet. I wonder if that's coming up. Well, son of a gun, here you go. Find the surface area of a square pyramid with side length 2. And 2, square pyramid means the bottom of this guy is a square, which makes sense why both of these sides are the same, because all sides are the same for a square. So we have this square pyramid has a slant height, meaning from the bottom to the top going along the side, so it's a slanted height of this square pyramid. We're going to find the area. Everything's in centimeters. Cool. So our units are going to be centimeters squared. Let's do it. All right, here's my picture. Hopefully yours is prettier. What in the dickens is this thing? Well, it's a square. So we know our area is going to be a square. Plus, we got these sides that are all triangles. They're all the same triangle, and they have to be because the square base is all the same. So these have to be 4 of the same triangles. So we got this front one, side one, this back one, and this other little sliver of a side one that I've drawn quite horrendously. So we'll have the area of a square plus 4 triangles. Cool. Well, what is the area of the square? That is this guy here. Square's area is length times width, so 2 times 2. We're going to have 2 times 2. Plus our 4 triangles. What's their area of a triangle? A triangle is 1/2 the base times the height. The area of a triangle is 1/2, just equals 1/2 base times height. Great. What is the base of this triangle? It's 2. What's the height of this triangle? The slant height, by definition, is always perpendicular to the base, so that's the number that we want. So that slant height is 3, so the height of the triangle is 3. So 1/2, 2 times 3. 1/2 times 2 times 3. So let's plug that into our calculator and come back with some answers. We've gotten 2 times 2 is 4, and 1/2 times 2 is 1 times 3 is 3, so we have 4 plus 4 times 3, so we have 4 plus 12, so we have 16. Our area is centimeters squared. I don't remember. Let's go check. But I'm 100% confident on that 16 number. Turns out it was centimeters. That is great. So let's plug in our 16. Let's submit our answer. Are we sure? Yes, we're sure. And Delta Math, you gave me the acknowledgement I needed with that green check that this was a correct answer. Our next question, holy what? We didn't talk about circles. We just talked about rectangles and triangles. Can we find areas of circles? Yes, of course we can. Totally, of course we can. So let's just read this problem and then we'll find what we need. What's the surface area of a cylinder with a height 6 centimeters? The height is 6 centimeters, so from there to there is 6 centimeters, and the radius from the center to the outside is 7 centimeters. Round your answer to the nearest thousandth. Okay, that means 3 decimal places. Everything's in centimeters. Cool, we don't need to convert. Great, answers are going to be in units squared. Fabulous. Height is 6, radius is 7. Alright, so here's our picture. What does this thing look like? Well, it's got a circle on the top and the bottom. It's got a circle on the top and the bottom. And then think of us as a can of soup. And then think about the label. If you unwrapped the label, it would come out like a rectangle, a long rectangle. So we need to find the area of these 3 shapes. We need to find the area of 2 circles that are identical. So our area is going to be 2 circles plus the area of the rectangle. Okay, great. We know the area of a circle is pi r squared. So we're going to have 2 times pi r squared, sorry, not h, pi r squared, plus, what's the area of this rectangle? How long is this side? We know the height of our soup label is 6. That's the same as the height of the cylinder, right? That's our height. But how long was this rectangle? Well, the rectangle wrapped all the way around the soup can. So the rectangle is the distance all the way around that circle. And the distance around the circle is called the circumference. This is the circumference. So the area of the rectangle is going to be the circumference times the height. The circumference, one more time, times that same height. Well, that's not bad. So we have the area of the circle. We have 2 circles. So we have 2 times pi times r squared plus the circumference, which is 2 pi r times the height. All right, well, we can do this. So we've got 2 times our pi, which we're going to use because they asked for the thousandths, right? They asked for the thousandths. So we're going to need to use more than just hundredths to get the correct answer here. So when we plug in pi, let's do a couple more digits than we normally do. 3.1415992. Or if you have a pi button on your calculator, that's what you should use. It has way more digits of pi than you would ever need, but it's going to give you the most accurate answer. If you don't have that, like I don't have that, on my little for function guy, I'm going to plug in just a bunch of numbers, 3.141592 every time I plug in pi. So 3.141592, 3.141592 times the radius was 7 squared, plus our circumference times height, which was 2 times 3.141592 times our radius, which is 7 times our height, which is 6. Alright, time for the calculated part, which is boring, so let's do that on our own and come back together. Should have gotten these longo decimos, which we add together to get 571.76973. We are rounding to the nearest thousandth. We are rounding to that position, so we look one guy over. 7 is definitely 5 or higher, so we're going to round up, which is going to round this to a 0, which rounds that one to a 7. So our final answer, which you can totally see now, is 571.770 units squared. Again, I feel like they were centimeters. I don't know. Not as concerned about that. More concerned about the actual number. It was units squared, so 571.77, not 9, 0, submit answer, totally sure, give it to me, hot, boom, shakalaka, check in the box. Alright, so let's do a quick little recap. What did we talk about today? We talked about surface area. What's surface area? It's how much space something takes up in 2 dimensions. We break those spaces down into rectangles and triangles and circles, which I didn't talk about at the beginning, but also circles, and then we find the area of each of those parts and add them all together. We can do that in a net, something that's already broken down for us, or we can take a shape and break it into its parts. We can do that with a, where's my other one here? We can do that with things that have triangles as well, right? We could do that. We had a square plus 4 triangles, not even a big deal. And finally, we did it with a circle. We did it with a circle. That is it, scholars. Welcome to the end of the surface area extravaganza. I hope you've had a great time. I love you so much. Keep on that hustle. And I'll see you in a bit. Peace.